Let's talk about representing sets. Okay, so I'm going to say a set of X, data definition, a set of X is a list of X's with no duplicates. Okay, so empty, for example, is always a set of X because there are no duplicates in empty. Okay, so let's write, I'm going to write a function called myMember, which takes an X and a set of X's, takes a sardine and a set of sardines, and gives you back a Boolean, depending on whether the X you give it is in the list. Okay, so we've already done this a few times, but let's do it again. Define myMember X locks. Okay. So, right, or map, right? I want to say, is there an element in locks which is equal to X? Okay, so I'll define myMember as local, define is X, define equal XY as equal XY. Okay, so this is, let's see, actually I don't want to do that. Let's call this other X. Okay, so this guy is a function that will take some other X and see if it is equal to the X that you're looking for. So now I can just say or map equal X locks. Okay? So I could have written this as a recursion, but we're exercising these functions. Now, here we've given this a name, which it's okay because we're inside a local, but in fact, one of the nifty things is that we don't have to give a function a name. We can use this thing called lambda, which builds a function without giving it a name. So this is exactly the same function. It's exactly the same thing, except that instead of creating this function and giving it a name, equal x, I've just said, yeah, for each other x, ask whether it's equal to x. Same function. Okay, and I passed that function directly to ORMAP. I didn't bother giving it a name first. And that works just fine. Okay. Let's try subset, What's the definition of subset? How do we know when set 1 is a subset of set 2? Okay, so you're asking whether every element of set 1 is an element of set 2. Okay, good. Now, what abstraction of the ones we've just talked about, what abstraction does that sound like? So, I'm sorry, I can't hear you. Let's see. You're asking whether you said set 1 is a subset of set 2 if every element of set 1 is an element of set 2. Okay? So you're asking a question about the elements of set 1, right? What kind of question are you asking about the elements of set 1? I didn't ask you what the question was. I asked you what kind of question it was. Are you, okay, so we have, your choices are map, fold-R, filter, and map, and or map. So the first question is, what kind of a value do you expect to get out? Right? What's going to be the contract for Boolean? Okay. Which of our abstraction functions, of the functions on page 302 that we showed just a minute ago, which of those produce Booleans? Does a map produce a Boolean? What does map produce? Somebody produces a list of things. Okay, which functions produce Booleans? Let's go back and look. Okay, yeah, well, let's see. Fold-R could produce a Boolean if you asked it nicely. Build list is never going to produce a Boolean. Filter is never going to produce a Boolean. Ah, here we go. And map and or map produce Booleans. Okay, so for subset, right, we ask the question, is every element of set 1 an element of set 2? Does that sound like an and map question or an or map question? An and map question. Excellent. Okay. Just got to get my mouse up here. And what is the question that we are asking of each element in set 1? Take a random element from set 1. What question are you asking about it? So the question I want to ask is in set 2 of X. Okay. Right, that's the question I want to ask. And now what I want to say is and map is in set 2. And I want to ask that question about every element of set 1. So now all we have to do is define is in set 2. How are we going to define is in set 2? My member! Yeah, we just did it! You don't have to think about it anymore. Right? That's the whole point of this game. Right? You do it once, and then you use it. And you don't have to think about it. Right? It's all about making your life simple. All right, say my member X set 2. There. Okay. Okay, good. Great. Now, how am I going to define set equal, huh? So I already have all the tools that I need. I just say and subset set 1, set 2. Subset set 2, set 1. And we are good to go. Right, I could of course just use a lambda there. Oh yeah, this is good. Let's do two more easy ones. Let's define set const Okay, so if set of x, if set is a set, right, so it has no duplicates, right, I want to define a new set that is just like it except with x, this new value x, little x joined, right? But I don't want to introduce any duplicates, but that's easy, right? Because I can say if my member x set, then of course adding x to the set doesn't change anything. Otherwise, it will be const x set, right? If x is new, that's easy. Let's try set union. So if I had these two sets, how could I construct their union? Do set const for every element in set 1. I like that idea. Okay, so what abstraction function should we use for that? So let me read back to you what I think you meant. Okay, so you're going to start with set 2, and then you're going to take each element of set 1 and try to add it to set 2. Okay, good. So what abstraction function does that sound like? Sounds like map. Well, let's see. Map has the property that it takes one list and gives you back a list of exactly the same length. So that probably isn't what you want here. Say again? Build list. Build list? Build list takes a number. Folder. Say again? Folder. Folder. Okay, I like that one. Let's try that one. Right. So we're going to take each element of set 1, and we're going to try to add them each in turn to set 2. Okay. So if set 1, what's our starting value going to be? Set 2. Right. So here we are. We start with set 2. And now we are going to, one by one, try to add the elements of set 1 to set 2. Okay, so what's our combining function going to be? Const? Say, I heard somebody say the answer. Set const. Okay, because what we're going to do is we're going to start with set 2, and now we're going to take each element of set 1. We're going to try to add it to set 2. What do I mean try to add it to set 2? Well, you see if it's there or not. Okay, and set const is exactly what you need. Okay, it takes an x and a set of x's, and again, set 1 is a set of x's. So you're going to have an x, and you're going to build a set of x's. So it is exactly what you want.